The supplement that I'm going to be covering today is carnitine. It is a water-soluble quaternary amine. It exists in two forms, D-carnitine, which is toxic, and L-carnitine, which is the biologically active component. The L-carnitine component is naturally occurring within the body. It exists in all animals. And within humans, more than 95% of the total carnitine stores exist in the skeletal muscle as free L-carnitine. This is the principal component of the skeletal muscle carnitine pool. It's also found as short, medium, and long chain esters, often called acetylcarnitines. In the skeletal muscle, the L-carnitine is a substrate for carnitine palmitoyltransferase, or CPT1. It's an essential role in the translocation of long-chain fatty acids. Those are those acyl groups into the mitochondrial matrix. And subsequently what happens is B-oxidation occurs. So realistically, what does it do? It's moving fat into the mitochondria in order to aid in exercise metabolism. It's also needed for ketone catabolism, for energy. And it also forms those acetylcarnitine forms from short-chain acyl-CoAs. And that's important because it helps to buffer the free CoA pool. Large quantities of acetyl-CoA are produced by glycolysis. So during high intensity exercise, these acetyl-CoA molecules will enter the mitochondrial matrix. It's preceded by the utilization of the TCA cycle. And then those L-carnitines, really their role is to regulate the ratio of coenzyme A to acetyl-CoA. And I should say that's its secondary role after mobilizing the fat into the mitochondria. So when it is able to regulate this ratio of coenzyme A, what happens is it results in ATP generation through the TCA cycle, and then it's also able to buffer the excess acetyl-CoA production when the rate of formation from the pyruvate oxidation are higher than what the TCA cycle demand is. So supplementation, right? Well, studies have suggested that co-ingesting carnitine with carbohydrate can lead to significant increases in intramuscular carnitine. Wall et al. Actually reported that exercise endurance performance was improved, and it seemed as though the improvements occurred from fuel selection and utilization. Now, if supplementation does demonstrate significant and meaningful results, then the people that would really benefit from this are our endurance athletes and our athletes that have those higher intensities for training purposes and their sport. Now, because carnitine does play a role in fat metabolism, some actually believe that it could be a slimming agent. However, the results are definitely unfounded right now at this point in time. So even though the theory seems logical, most of the data around it is continuing to suggest that carnitine supplementation really does not have an effect on muscle carnitine content in fat metabolism, exercise performance, or weight loss. Now, it's definitely apparent that more research is needed regarding the changes in performance, but truly we need to look at it before we can really recommend this type of supplementation. Now, who would need a supplement? Well, if you have a deficiency in carnitine, it would probably be a good idea to supplement. These cases are extremely rare. However, if you were to supplement, you could potentially increase plasma and muscle carnitine concentrations. This would be beneficial for some people with specific cardiac problems, diabetes, but the big thing is it does not burn fat as suggested by advertising.